Okay, this is week 5 in AGEC 305. This is our class meeting. Our Friday class meeting is online lab. I think everyone has figured out now that we're not meeting on Fridays except for some optional meetings. We have one of those coming up in week 6 where we can review. We will spend some time reviewing midterm exam materials. To advance. There we go. Yeah, so we're gonna cover a new topic today, and in this lab, it's called equilibrium displacement modeling. So this will be your introduction to working with elasticities, or as I mentioned in class recently, some people call this back of the envelope. So BOTE, back of the envelope analysis, or there's a famous paper called Economic Analysis on the Back of an Envelope that sort of describe these results. Everything starts from the idea that we've worked our way up to. Okay, so we've both empirically looked at what a demand curve looks like, and prior to that, so that's been our topic for about 2 weeks now. Prior to that, we spent our time thinking about supply and demand interactions. So the force of supply, the force of demand, working in a market. And we've made some assumptions. We've said supply in our models has been linear for the most, exclusively linear and upward sloping. Demand has been linear and downward sloping. We did play with some estimations, some empirical work where we let demand not be linear. We let it be curvilinear, or it had some properties that allowed it to adjust in a nonlinear fashion. Either way, we say that supply, the law of supply, holds up. It has a tendency, the tendency is for expanded quantity supplied as prices increase, and for demand, that tendency is exactly reversed, right? So as price goes up, the quantity demanded tends to fall, and so those are opposing forces, and so that's why we draw it this way, and we say where they cross, the forces are balanced out. There's a price and quantity combination that sits here in this market where those tendencies tend to balance out. There's no incentive, right? The suppliers don't want to make more. Consumers don't want to reduce purchases by any more. They've found this sort of balance point. And that equilibrium, we call it equilibrium because it's this stability point. It's this idea that if nothing changes outside of this system, right? So in this picture, we have the demand force, the supply force, as they are represented by price and quantity relationships. So if nothing changes in those price and quantity relationships, that equilibrium point perpetuates itself. It has a tendency to just stick. You need some outside force, some disruption from the outside, some shock that would cause this to move. And that's where we moved into the idea that supply could shift this way or this way. Demand, the same thing, could shift. But those come from outside of the price and quantity graph. Okay, we got price there, quantity here. There's nowhere to show what happens when income changes, and so what happens is we replace this demand curve with a shifted demand curve that represents the income dimension having adjusted. And that's where we've moved in this slide. So the demonstration of a demand shock from the old demand to the new demand. The old equilibrium point gets replaced by a new equilibrium point. So I've got Q star, P star, and then just the new one is represented with double stars. The demand shock impact is to increase the price in the market and increase the quantity. Okay, so we can say that given the way we've represented this market, if there is a demand shock and it's positive in that it generates higher quantities demanded or higher quantities transacted in the market, that it will be price increasing. That's from the law of supply and demand, the tendencies of those forces to be downward sloping and upward sloping. The demand shock impact is to increase the price. We call it a positive demand shock. And then here is the key part, the thing we've been working on. So one of the reasons we've been investigating empirical demand work is to try to understand sort of the variety, right? So in looking at data over time, how do we know these actual responses so that we're not just drawing graphs and making assumptions, or just putting together sort of fake synthetic examples where I give you the numbers and I hope that they work out well so that the math is relatively simple. So we've been into the empirical work to try to understand just how responsive these demand curves can be to price or to this outside force that causes a shock to demand. And the reason we do that is because to measure the change, to understand the change in the market, which is really what we're focused on, and really in this class we're focused on how the price adjustment occurs, we need to know three things. One, the size of the shock, right? So how big is the thing, right? So we know it's something from outside the model. It's not prices or quantities. We know it's not one of the two variables on this graph. Whatever that variable was, let's just say it's income. That's what we're going to work with as an example here. There's an income shock that causes this change. We need to know how big that shock was if we're going to understand how the price change happens. The second part, we need to understand the supply response. We need to know what the tendency on the supply curve is, because we're actually going to follow that path, right? So this demand shock is going to take us up the supply curve to find the new demand. And we also need to know the demand response, because we need to know how steep the demand curves are that are being shifted. Okay, so those are the three things we need. That's sort of the full picture of what's going on. So we're going to put together a model this week that tries to take us through that kind of calculation to understand how prices adjust relative to those three components. Okay, so our last two components that we talked about there were supply and demand response. Let's take our supply equation, demand equation that we've been working with, the linear versions of those, straight line supply and demand, and think about what the response part is. So if you take this equation, quantity supplied is equal to A plus BP, well, the part that tells us how price and quantity respond to each other, how quantity supplied responds to price, is just the B, right? So any changes in price will show up as B times P, giving you the change in the quantity supplied. A exists just as an intercept, right? So it doesn't tell us anything. It tells us about the ultimate level of quantity, but it doesn't tell us about the response of quantity when price is moving around. So in that sense, it's the slope, and so the slope is the supply response in this linear equation, and we could write it in derivative terms. Change in quantity supplied per unit change in the price is equal to B, and we get the same exact, right? Because we're writing these as linear functions, and the only thing that's changed is instead of the quantity supplied, we're thinking about the quantity demanded, and we're giving it new distinct parameter names, C and D. So in this sense, if we looked at this, quantity demanded is equal to C plus a slope parameter multiplied by the price. Then the demand response is linear, and we get the same result. So if we wrote that as a derivative, the change in the quantity demanded divided by, or per unit change in the price, is equal to D. And we have two measures of response, B and D, that are essential, right? Those are critical numbers for us to know if we're going to measure the impact of some shift to demand, because we need to know the initial and the old and new equilibrium, because we're thinking about shocks, and we need to know where those things are going to balance out. So we need to know the equilibrium conditions or the equilibrium tendencies, how much of it comes from the supply side and how much of it comes from the demand side. Economists traditionally do not focus on the slope measures, though. There's a lot of reasons for that. Mathematically, if you want to move away from linear supply and demand, then we saw this in the Wednesday's September 20th of 2017, if that's when this video is being watched, lecture that there are all kinds of complicated ways of writing different slope parameters, or sorry, I guess it's like this. The change in quantity per unit price can be pretty complicated if you have a more complicated formula. And so because of that, that's not sort of a universal language. The universal language of thinking about response for economists is the elasticity. So economists tend to focus on this. You may have heard of it as unitless because it's sort of this index. It's this sort of measure of speed, in the proportionate changes, right? So which is moving faster, quantity or price? It's a ratio of percentage changes that when people say it's unitless, that means you could cancel everything out if you wanted to. We tend to preserve the percentage change part because it's a great way of describing what's going on. So we focus on elasticities for evaluating or describing responsiveness because we can always, whatever functional form, right, remembering what we've been doing recently and remembering the lecture where we went through all those different ways, the complications, right, that come about in calculating elasticities depending on whether you are imposing homogeneity or not. All those different pieces go away. If somebody just shows up and says the elasticity of demand, the own price elasticity of demand is negative 0.8, you don't have to move back in time and say, well, how did you find that? How did you get that? If they tell you that's how they want the analysis conducted, that's what the assumption they want for how demand responds, then you move forward with that. Okay, and so let's do some review on elasticities. It's the percentage change in quantity given a percentage change in price. Okay. When we have something that's very responsive, this is all supposed to be review material, we call it elastic. And elastic just means that the quantity moves proportionally more than the price in absolute value. So it means the numerator is moving bigger in absolute value than the denominator. Okay. So when you calculate this, that just means that you'll have an elasticity that's larger than 1 in absolute value. Things that are not responsive are called inelastic, and that just means that the quantity moves proportionally less than the price, again in absolute value. And so you'll have numbers that are closer to 0, right? Or in terms of absolute value, that means the elasticities will be below 1. Okay? For demand, they'll be between 0 and negative 1. For supply, they'll be between 0 and plus 1. When things are equally responsive, that means you get an elasticity that means you get an elasticity that's exactly equal to 1, and they just move proportionally. The quantity and the price are moving at the same rate, right? So it's a 20% change in the price causes an exact 20% change in the quantity. They move at the same speed. And we call that unit elastic. So those are the 3 categories of elasticities that we have, and they work on either side of the number line. They work for positive numbers for supply, use the same definitions for demand, and that's why we use the absolute value part there. So we have 3 categories, and once you add the absolute value out here in these, that means that you can use them for positive and negative. And you don't have to sit around and think about, well, demand is negative, so being lower or less means being more negative, right? And so if you switch to absolute values in your mind, or think about it as, absolute value basically tells you the distance from 0, then you only have to learn 3 definitions and just remember how to apply them to multiple situations. Okay, so we need to do some work with our elasticities. Let's start. Let's specify separately the elasticity of supply. Here I'm going to, in this lecture, and I'm sorry I'm not more uniform in this, but in this particular slideshow it'll be capital E subscript S, and the elasticity of demand will be capital E subscript D, and those are own price elasticities. So it's very common when you hear the word supply elasticity and demand elasticity, if there's been no other reference, just assume it's the own price response. Okay, I have definitions here in percentage change terms. So the supply elasticity is the percentage change in the quantity supplied divided by the percentage change in the price. And the same thing for the demand, except it's now the percentage change in the quantity demanded. And the reason we go to this step is so that we can see that these are actually equations, right? So this is a number that's equal to a number divided by some other number. And if we took the brackets here to be like holders for variables, the thing inside of this is something that we can measure, And so the change in quantity supplied, or the percentage change in quantity supplied, is an actual measure. Then we could rewrite each of those expressions to look something more like an equation. And that's what I've done in these two steps. So if it's the case that ES is equal to this change divided by this change, then it must be the case that you could solve for the percentage change in the quantity supplied, and it would be equal to the elasticity multiplied by the percentage change in price. You get the same thing here. The percentage change in the quantity demanded from right there must be equal to multiplying both sides by the percentage change in price, so that you end up with an expression that looks like this, where this quantity demanded adjustment is equal to the elasticity multiplied by this percentage change in the price. And so these brackets, right, that I'm using to hold this, they're essentially their own kind of variable, right? So we can do variables of any kind of units, and in this case I'm bracketing these things to be to indicate that I want these to be treated like variables, things that we would be interested in solving for. And so let's make that more of a formality and work with, in our second slide on elasticities, let's define variables that have the units percentage change in quantity supplied, percentage change in quantity demanded, and percentage change in price. So those become the descriptions for the variables, and when you read a result, or when you solve for q lowercase q sub s, you interpret that as a percentage change. Okay, so it's measuring if the number that you solve for is 5 for QS, or the number that you're given is 5, it means quantity supplied changes by 5%. Okay, quantity demanded changes by whatever QD is. The price changes by whatever percent is measured in P. Okay, and so we just treat these will just be numbers, and those numbers carry these units, percentage change in, percentage change in. And so we can rewrite our equation from before, these expressions that have brackets to hold all this description, and say we're just going to substitute into those brackets these variables that I've declared that subsume, or they have these as definitions. So it's now just lowercase qs is equal to the elasticity of supply times the percentage change in price. Percentage change in quantity demanded is equal to the elasticity times the percentage change in price. So it's everything we just did rewritten with new symbols, and we want these symbols to be variables, so that trigger them in your mind when you see these, to think of what they are. And as a convention in this class in Ag Econ 305, I can't promise other people would do it the same way, but I will always use lowercase letters like this to indicate a percentage change version of a variable. Okay, so if you back up a few slides, you'll see that we had QS and QD in capital form here. Those were the levels, and so one of the traditions and people who do this kind of economics is to make lowercase versions the percentage change variables. Okay, so in these variables, we can specify these using any units we like. Levels variables are measures of the level of quantity supplied. QS, QD, and P, these lowercase versions, are just variables with percentage change as their units. Okay, so they numerically, algebraically, everything works the same. You just have to keep in mind when you go to interpret something, you are not saying the quantity changed by 5, it changed by 5%. Okay, so why might this be useful? Well, let's consider what's going on here and what we're really interested in. Somebody tells us this was last year's equilibrium point, and they tell us that there's an income change that happened. It's been forecast. Everybody, there's this demand for workers that's caused wages to go up by 10% or whatever, that's generated this income shock. And that income shock is going to have a demand effect, and so we need to be able to forecast or to pull that out. And we may not have enough information to go back and construct the full demand curve and supply curve, but if someone can tell us what they approximate the demand elasticity and the supply elasticity to be, and tell us something about the income responsiveness of demand, then we have all we need to do to calculate what's the percentage adjustment in price going from the old equilibrium to the new equilibrium. Okay. So there are a few things here that we can learn from this. So the change in price is the same if you measure it using the supply curve by tracking upward, or measure it using the two different versions of the demand curve. The percentage change in quantity supplied is exactly equal to the percentage change in quantity demanded. So that's the second piece that's going on. So these two factors, the fact that we could use supply or demand to measure the price impact, and that because it's going from one equilibrium to another, this change, whether we measure it using quantity or supply, it has to be the same, means that we can write our equilibrium condition or our market clearing condition in terms of those percentage change variables. So from 1 and 2, we can write our equilibrium condition, and we would just write it like this, where, the subscripts seem to have disappeared, but this is supposed to be lowercase q sub s is equal to lowercase q sub d. Okay, it's basically says that the percentage change in the quantity supplied will be exactly equal to the percentage change in the quantity demanded at the equilibrium. Okay, so the equilibrium adjustment says that those two things will hold. Okay, and then when we call this model, because of the way we're doing this, so this is called equilibrium displacement. It says pick an old equilibrium point, or the initial equilibrium point, and instead of trying to describe all the demand equation and supply equation, let's just try to describe the quantity and price adjustment from this dot to this dot. And so in some sense it's think about how to displace the old equilibrium to the new equilibrium and describe it that way, and that's why we call the models equilibrium displacement models. It's an analysis of the movement from one equilibrium point to another using elasticity equations. So these are equations written directly using the elasticities that we either measure or assume. For the supply equation, we can just use the one we already built. The percentage change in the quantity supplied is equal to the elasticity times the price. For the demand equation, we're going to need one extra piece, right? So we're trying to model this demand shock, right? The old demand is picked up and replaced by a new parallel demand curve. So we need a shock variable that moves the quantity and price equilibrium. Let's use income. That's a simple one. And so I need a couple more definitions. I'm going to add lowercase y. Let that be the percentage change in income. Okay, so just like we're measuring price and quantities in percentage change form in this kind of modeling, this displacement modeling, we need to measure any of our shock variables in percentage change form as well. Okay, so we measure the income as lowercase y, it's the percentage change in income, and we need to know what the income elasticity of demand is. And I'll just write that as E sub y. That makes our demand equation the percentage change in the quantity demanded is equal to the own price demand elasticity times price plus the income elasticity times the percentage change in income. Okay, so 1, 2, 3 percentage change variables and 1, 2 elasticities. Okay, both of these elasticities describe the partial response. How does this quantity demanded percentage change respond to a percentage change in the income? How does it respond to the price? And so this equation gives us one chance, and we'll come back to it as we get a little further into this in lecture. Remember our homogeneity test. our homogeneity test says that if you add the demand elasticity to the income elasticity, you should get 0. And so that says that if you balance all these out so that price increases by 1% and income increases by 1%, this change here should be exactly equal to 0. Does this hold up? Probably not. Depending, I mean, it would depend. We would have to enforce it. But as we move through this class, thinking about these things, that's something we're going to come back to. Right now, we just want to learn the technique of solving for these percentage change models and see how it squares up against our levels models, and then we'll come back and think about that homogeneity result once again. But I guess the point is, our most recent exercise from lecture had us adding up all the elasticities of demand, and I just wanted to show that that's exactly what's going on in this equation here. It says the total percentage change in the quantity demanded is equal to the component contributed by the on price demand elasticity and the component contributed by the income elasticity. And then on this slide here, right before, we were working through what we're trying to establish is that yes, we can write an equation that says the percentage change on the quantity supplied side will have to be equal to the percentage change of the quantity demanded side, because they are moving both the supply and demand are moving from the same old point to the same new point, so those percentage changes have to hold up. Okay, so we've got 3 equations just like before. Just like we had with levels, we have a supply equation, a demand equation, and one that describes market clearing or the equilibrium condition. And we would solve it just like we did our linear model. So let's take, if QS is on the left-hand side here, and it's also equal to the supply elasticity times the percentage change in price, then we can write it and substitute it in for QS. And the same thing for QDs. Here, the percentage change in the quantity demanded. Take the right-hand side of that equation, substitute it here, and you have an equation in 1, 2 now percentage change variables. But one of these percentage change variables, lowercase y, is actually our shock variable, right? So that's the thing that's outside the system. And so that variable is okay. We don't need an extra equation to solve for it. We're going to be given that as our exogenous shock. So lowercase y is going to be exogenous here. So here's how to think of this. If you're doing algebra, this is the coefficient, this is the variable. Coefficient, variable, coefficient, variable. And so when you're trying to work with these, that means you could subtract this coefficient times this variable from both sides, so that the new left-hand side is now the supply elasticity times the price minus the demand elasticity times the price, and it'll be equal to the income elasticity times the percentage change in income. You can factor out, just like we would do in regular algebra, if a coefficient, if 2 terms on the left-hand side here have the same variable and only differ by the coefficient that's multiplying them, then you can use the, whatever algebraic property, distributive maybe, to factor out that percentage change in price, so that you're left with, in brackets, a new coefficient for price that's the elasticity of supply minus the elasticity of demand. The right-hand side stays the same. And so once you get this, we can solve for our price impact equation, right? This class is ag prices, and we're trying to understand price impacts. So percentage change in price, when we solve this, will be equal to, in the numerator, the elasticity of income times the income shock, or the percentage change in income, an exogenous term. And that will be divided by, to give us this price impact, it will be divided by the supply elasticity minus the demand elasticity. And this should be familiar. We had that price analysis equation from the linear system where we said, let's look at P star, and you end up with one component that is sort of the basic equilibrium price with no shocks. And then we had another term, I wish I'd written it on the slide, but I didn't. but we had it in quiz 3. You can see what one looks like. And then we had another term that says this is the impact of the weather shock, and then we had another term that was the impact of some demand shock. Maybe it was income there. And so this is similar to that, except it's much simpler here. This says the percentage change in price is equal to the effect of income, the income shock, divided by the supply and demand elasticities. Okay? So this combination of the supply and demand elasticities is sort of the speed of adjustment, right? So we've talked about the slopes being a measure of sort of the total speed of adjustment. Well, the supply elasticities are also that, right? They're comparing the quantity versus price adjustment. And so if you put them together, you get something like the total adjustment speed in this model. So you get the size of the shock, the total adjustment speed. That ratio is going to tell you how much the price changes. And think about it this way. So instead of solving for a basic price like we did in that P star equation from our levels investigation of supply and demand, right, using capital letter variables or whatever you want to, however you want to think about it. Think about this one. What if the income shock is 0? Well, the entire numerator here goes to 0, and this says if there's no shock, if there's nothing here to drive the change, then the percentage change in price is equal to 0, and that just means back here, if the percentage change in price is 0, you're just sitting at the old equilibrium point. When the percentage change in when the percentage change in income starts to adjust, the price is going to start moving up, and it's going to follow this path. And that's why the supply and demand elasticities are in the the denominator, to capture that path of adjustment. Okay, so this percentage change in the market price, our price analysis equation from this model, basically just says the market price depends on the shock, the part that comes from outside the system, how much did income change, and how does the demand side of this equation, the demand side of this market, respond to income changes. And then the second part says the supply and demand response. So those are the 3 components we said we needed to know about. We have all 3 of those in this price analysis equation, so we are all set. It's consistent with our linear supply and demand, where we indicated the shock and the supply and demand would all have a role to play. And the other thing that's important and really useful, it says why the back of the envelope, where it gets its name, is this is generic. This result, as it's written right here in these 2 bullet points, is always going to hold up. It doesn't matter if you're doing an income shock, a population shock, a preference shock, a ban on certain consumption types that causes people to shift. Whatever you're doing, it's always going to be in these equilibrium displacement models. The percentage change in the price is going to be determined by, in the denominator, the ratio, the difference in the supply elasticity and the demand elasticity. Okay, and you remember demand elasticities are negative, so this in fact becomes like the total speed of adjustment in the market, and it's always going to be in the numerator whatever the shock is. However we describe the shock, it'll be some elasticity times some percentage change that describes this outside adjustment, this outside influence, or this outside disruption or displacement factor. Okay, and so that result means that we can do equilibrium displacement in sort of shorthand analysis, write the price equation, think about what elasticity and percentage change we're considering for the shock, divide those by the supply and demand elasticity assumptions, and we have an automatic way of taking elasticity information that might be given in a research report or might be produced by an academic, right, from a journal paper. Maybe we don't want to read the whole paper. We see that they've reported that the demand elasticity for pork is negative 0.2, and the income effect but the income elasticity is 0.5. And so we might take those 2 results, come up with some assumption about the supply elasticity, and think about how income adjustment will cause demand for pork to change. Okay, so that's what we're doing. our last piece here is going to be to build a linear in the levels model and see if our percentage change result holds up. So we're going to jump out to the spreadsheet that you have. This is what the spreadsheet you have looks like. So it has two columns, a base equilibrium and a new equilibrium. I'm going to add formulas with you for the equilibrium price, the equilibrium quantity, the supply elasticity, the demand elasticity, and the income elasticity, all measured at the equilibrium point. Okay, that's something that I haven't brought up yet, but that I should. It depends on, it always matters. Elasticities always matter where you measure them. And so for this equilibrium displacement modeling, the elasticities may be changing, but for the equilibrium displacement modeling, the demand elasticity is changing as you move down the demand curve, but the equilibrium demand elasticity is measured at this exact point, the old equilibrium point, and that's the one we want to use. So let me jump back to this. And so what we're going to add here are formulas to measure the supply, demand, and income elasticities exactly at this point right here, the equilibrium point. There's no way to calculate percentage changes, so you'll see that's blacked out from the base equilibrium. We only calculate those from the new equilibrium relative to the base equilibrium. And then because we're doing this displacement modeling, we don't really care about what the new elasticities are because they will change as you move the equilibrium point. But we're always considering those from the base point. Okay, so and then we have up here, just let me point out what we have for the supply equation. We have just an intercept and slope. For the demand equation, we'll have an intercept and slope. Those are for the price, in the market. But here, the income parameter that I'm giving you is a second part, a shifter of demand, and then we'll say the income level of 50,000. And that's the thing that we'll need to shock, right? So the change between column 1 and column 2 is going to be you putting in a new value here in place of these double question marks that replaces 50 with some percentage change, some increase to income, increase or decrease to income, some income shock. And so this cell here is, I think it'll have like an outline around it in the spreadsheet. In linear equations, terms, levels, right, of the variables, so the quantity supplied, the actual measure of quantity supplied is just equal to the price. The quantity demanded equation looks like this, except looks like that's 0.5. That got dropped. So there's a decimal point that's supposed to be sitting right there, plus 1 times the income, and we get that. Okay, so I'm going to open my spreadsheet now. And you can just follow along and fill it in. So I'll try to go slow, but you can also look through your notes or through that extensive handout one that we had, and you can remember these things. So okay, the starting point for the price formula is always going to be the demand slope, or sorry, the demand intercept. Subtract from that the the supply intercept. Wow, I should have written a script for this. So B7 minus B3 is what I have so far. So the demand intercept minus the supply intercept, and then shocks on the demand curve get positive signs. Shocks on the supply curve get negative signs because they're basically just shifting of the intercept. So that means we're going to add the income term. Okay, so the income term here works as our shift to demand, and so I need to take the income parameter in B9 and multiply that by the income level in B10. Then we need to divide all of that, and it looks like I missed an open parenthesis, so click over there and put an open parenthesis in front of B7. So all of that term is the numerator, and then remember our denominator so I put a division sign and an open parenthesis. Our denominator is always the supply slope minus the demand slope, because the demand always, the slope of the demand curve is always negative, and that means that when we subtract it, we're actually getting a plus, so the total speed gets measured as 1 minus a negative 0.5. Close that parentheses off and hit equal. I'll let it sit there for just a second so you can see all of the cell references as they go. Hit enter and you get 100. The quantity equation is pretty simple. You can use either equation. Just remember, if you use the demand equation, you need to use this intercept and this slope multiplied by the price, but you've got to add to that the income parameter times the income level. I'm just going to use the simple one and say that quantity can be measured from the supply side as the 0, or B3, the intercept, plus 1, the supply slope, multiplied by the price level I just calculated. So I'll let that sit there for just a second. So B3 plus B4 times B12. And we get the solution. So we have P star is equal to 100 and Q star is equal to 100. Now, it's possible that you want to just drop the B3 from this equation. I would suggest you don't, because what if in your quiz this week I ask you to change the intercept of supply from 0 to 20? Well, if you did that and you forgot, or you said that's 0, I'm going to leave it out of my formula, then you would get the wrong answer because you wouldn't show up as a change. So even when something doesn't matter the way we're putting the formula in the initial situation in these spreadsheet models, I just want to take this time to encourage you to put the true equation in, even if right now the assumption is 0, because you might get better information and it's not obvious. If you leave that out, there's no like computer code to go back and check all this stuff. Okay, we have a couple more things to do. So the elasticity formulas, if you remember, go check your notes from class, slides, whatever. But it's just going to be for these linear models. It's just going to be for the supply elasticity. We take the slope of the supply equation, and then we need a measure of P and Q, right? So it's the slope of the supply equation multiplied by P divided by Q. And because we're doing these elasticities at equilibrium, we want to use exactly this price and this quantity here. We want to measure the elasticity. My bad. We want to measure the elasticity at the equilibrium point. So we go with B4 times B12. Put a division sign in, and B13. So I'll let that sit. So B4 times B12 divided by B13. And we get the elasticity of 1. You might remember from AGEC 220 if you had it. If the intercept of a linear supply equation is 0, the elasticity of supply is always 1. Let's calculate the demand elasticity. That's going to be the slope of the demand equation multiplied by P, the equilibrium price, divided by Q, the equilibrium quantity. Okay, I'll let that sit for just a second, but it's always slope multiplied by the ratio of P over Q, and since we're calling these the elasticities at equilibrium, those are going to be the ones we want. So the elasticity there is negative 0.5. Our last piece is the income elasticity, and so we went through these in class for our linear system. It's just going to be the sort of slope parameter. Here's the income parameter. It's how does the quantity demand change for every dollar of income, or in this case every $1,000 of income we get a 1 unit increase in demand. And so that's the slope parameter, or the DQD, or the D quantity divided by D income, is just this value. Okay, so we take B9, multiply it by, not the price this time because this is income, but we multiply this one by the actual income level. So it's going to be QD over dy multiplied by the income divided by the quantity. So we're going to multiply by 50, and then we'll divide it by the quantity demanded of 100. So B9 times B10 divided by B13. Let me see if I can. Yeah, add for you here. So the elasticity of demand, let's add that. Could be written as like EY equals DQD. Let me do it this way with brackets. So we get DQ divided by dy. That's sort of the derivative part. And then the second part is always whatever's in the derivative, Q over Y, flip it around so that you get Y over Q. Okay? And so maybe that'll help us to remember. But you can also find that again from the notes that we just did. Okay, so we got 2 formulas here that we need to copy because the price and quantity formulas of the solution to this model are always the same. So just whatever. Oh, sorry. Yeah, just drag those over. And for right now, we'll just set the income level the same to be sure that we're getting the truth here. So because the new equilibrium price and the new equilibrium quantity depend on income, when you put the question marks there, it doesn't know what you're doing. So so let's do those, and then we have 3 more formulas that I want to add, and those are percentage change formulas only for the new equilibrium column. Okay, and if we do these correctly, we should get a 0 for all of them. So let's go with the percentage change in the price. How do you calculate it? Well, we could put 100 times, okay, 100 gives us in percentage terms the new price here minus the old price from this column, and then what do we divide by? Well, we divide by the old price, right? So it's something like this. 100 gives us percentage terms, C12 minus B12 gives us the change in the price, and B12 in the denominator gives us the original price. So it's the change over the initial value multiplied by 100, and then we end up with that value. We'll do the same thing for quantity. So I'm going to do 100 multiplied by, open parenthesis, the new quantity minus the old quantity. So that gives us the delta, or the change between the two terms, divided by the initial quantity. I'll leave that sitting there for a second, but that's the formula we want to use. And then the same thing for the income. So we'll go with equals 100 multiplied by, open parenthesis, the new income minus the old income, close the parentheses to make division, and then use the old income again as the base. So 100 times, in parentheses, the change in income divided by the old income. Alright, so what do we got to do now? Well, we need some tests, right? So we put in the formulas, and we need to check our work and see if everything works and adjusts. So what would be a useful test here? Let's try something like a 6% increase in income. And so 6% of 100 $100,000, well, 100, this is in units of 1,000. 6% of 100 would be 6, so 6% of 50 must be 3. So let's make the new income $3 or 3 units higher than the base equilibrium. And so let's just put that in. Okay, that checks out, so we end up with a 6% increase in income, and the new equilibrium solution shows up right here, right? So we get the old price, the new price, the old quantity, the new quantity, and it says those are both 2% larger than the original. Okay, so this 6% shock to income that we instituted right here, going from 50 to 53, gave us a 2% change in the market price and a 2% change in the market quantity. Now, that gives us a test to go back and look at our equilibrium displacement model. So let's make note of this. So both the price and quantity increased by 2%, the income increased by 6%. If our result from our result right here tells us if you want to calculate the percentage change in price, all you needed to do was take the income elasticity here, multiply it by the percentage change in the income, and then divide that by the the supply elasticity with the demand elasticity subtracted from it. And so we can test our back of the envelope work right here in the spreadsheet. So I'm just going to add the formula right here that would come about from the equilibrium displacement equation on the last slide. And so let's use this with our, sorry, I want it right there. So let's go with percent change in price. Right here, our prediction for the percentage change in price is just going to be, we have a numerator. Come on. Our numerator is going to be the income elasticity. Okay, forget it. So it needs to be parentheses, I guess, in Excel. It needs to be parentheses, sorry. It's going to be our income elasticity multiplied by the percentage change to income that we have over here. Okay, so we calculate the base income elasticity, multiply it by the 6% change to income that we've shocked, right? The 50 to 53 was the 6% change. Close those parentheses, and then we're going to divide by the supply elasticity minus the demand elasticity. Close those parentheses. You can put this formula in for yourself if you want. And I'll let it sit there for just a second. So it's B18 times C23 divided by, and this is the parentheses will be important here, B16 minus B17. Click enter, and you get 2. And you can probably see that on your own without doing that. So what have we found? We found that our spreadsheet model that has all this information that we need to calculate these two gives us the same results, and that's because the elasticities results, or these equilibrium displacement solutions, are linear approximations. So they're approximations moving out a supply and demand curve that is straight line in behavior. And so that means that if we can calculate, if we can either have all the information necessary to construct a supply and demand curve like we have here, or if we just have some information on the elasticity of supply, demand, and income, we could do predictions on how the price will change in the market as income changes. Okay, and so that can be a very powerful thing to do because it's much easier to find information on elasticities than it is on the full set of information necessary to build a supply or demand curve. Moreover, we have really good ideas about what elasticities are. We believe in general that supply elasticities for major crops, food crops in the U.S., tend to be inelastic, and food demand tends to be inelastic. So we can get results that are consistent without knowing, just using the elasticities or good assumptions for the elasticities that are in the right range, and try to understand how big we expect price jumps to be as we see things like income adjustment happen, or a classic case is something like a food stamp program or a SNAP program, where you are giving voucher income to be spent on food. So what is the effect of, let's say you increase it by 10%, the value of those vouchers for buying food? What is that effect? Well, an equilibrium displacement model would be a perfect situation where you try to go and understand how that income side demand effect might affect prices for other people. Okay, will it tend to pull up the prices, or is it so small that it won't have any effect? So that's the kind of things we can do. With that, we'll close out our lab. Hopefully you've built the spreadsheet out and we're able to get it to this point. This last piece here won't matter as much. So if you followed through, then there will be a quiz. There's a quiz posted online. It's an online test or an online assessment that goes with this lab. So just go use your spreadsheet to answer the first 3 questions. And then I think questions 4 or 5, as they're written, you should be able to answer using this expression right here. So just jot it down, use the assumptions that are given to you, and do those calculations. So it's a quick assessment, no getting a new document open and typing up a bunch of things. We got the exam coming up, so I just want some kind of quick thing that you can post online that shows that you took the quiz. I think it's marked at like 50 points, but you'll get 50 points just for submitting the thing. But you should be able to get all these questions right there. Just check yourself. Okay, so that'll close out our Lab 5 and our introduction to equilibrium displacement modeling. We will have a chance to look at this in more depth as we continue our work and lecture on these kind of models.